Okay, this is just a review of the strong acids and strong bases that you need to know and what makes them strong. We've learned before that they completely dissociate or completely ionize. So I'm going to write completely ionize. This is just a recap. That means that the arrow is going to be a complete forward, not equilibrium. Okay, doesn't go backwards, they completely go to the right. Okay, there are 6 you need to remember. My phrase or word, I guess, to remember them is bins. And then I know that there's 2 chlorines. So this is hydrobromic or HBr. This is hydroiodic or HI, nitric, HNO3, and sulfuric, which is H2SO4. And then my 2 chlorine ones are HCl. And then the one that has a bunch of oxygens on it, it's HClO4. Okay, so those are the 6 that you need to know are strong. So if you see this in a reaction, you should know that it is strong acid. Okay, now if I want to talk about the conjugates of these guys, right? Now, if it completely goes to the right, that would mean it doesn't go backward, right? So that means the conjugate bases of strong acids really aren't basic at all. They can't do anything. Okay, so they are extremely weak slash not bases. I'm just going to write not bases. They can't act like bases at all. Okay. Now, as we start talking about weaker acids, so if a strong acid has a very, very, very weak conjugate base, that means that weaker acids actually have stronger conjugate bases. It's really a spectrum. Okay. So for example, HCl, sorry, that we know is strong. I have a full right arrow there, turns into Cl minus plus H3O plus. It can't go backwards, so that means that this right here is really not basic at all. While it is considered its conjugate base, it really has no basic properties. It can't actually act as a base. Okay, same thing, but opposite for strong bases. Of course, they are also going to completely ionize, meaning I get a full to the right arrow. The ones that you need to remember are the group 1A and 2A. So the alkali metals and alkali earth metals with hydroxide. Okay, so they're always going to have a hydroxide. There's a few that we don't include to remember on that list. Some hydroxides are really insoluble, so they don't really considered as strong bases, but you don't really have to worry about that until we get into solubility. So don't stress. And then example wise, if I were to write this, okay, we already said I put this in water and it turns into Na plus and OH minus. Okay. This is essentially basic, right? And it can't go backwards. So its conjugate acid really can't be an acid at all. Okay, so I just want you to keep those in mind for strong acids and strong bases.